low-velocity explosive actuated tools work on the principle of a cartridge detonating against a piston, which then acts against a fastener. Manufacturers may vary the size, style, and special features of this kind of tool, but not the principle. This principle is illustrated here. The low-velocity tool uses a powder charge, which, when detonated, imparts energy to a piston, which in turn pushes the fastener into the material. Because of the fairly large mass of the piston, a speed of less than 90 meters per second is all that is needed to drive the fastener. With low-velocity tools, as soon as the piston stops pushing the fastener virtually stops. Therefore, there is no need for an elaborate guard system. However, most manufacturers supply a simple guard which clips or slides onto the muzzle end of the tool to retain particles that may become dislodged as the fastener enters the material. Every operator should be familiar with these parts of a low-velocity tool. At the butt end, it has a pistol grip and a firing pin mechanism. At the opposite end, it has a barrel housing section, which contains the following parts. The cartridge chamber. This holds the cartridge in place during firing. And it also has a provision for extracting the fired cartridge case. A compression spring keeps the base plate extended when the tool is not being fired. The piston, which pushes the fastener into position. The stop ring, made of soft metal, serves as a buffer or protector between the piston and the piston housing. It will compress if the piston is overdriven. The stop ring fits into the stop ring holder. This cylinder section holds all the parts of the barrel assembly. Other parts of the tool are the retaining ring, which attaches the barrel assembly to the barrel housing section, and the base plate, which acts as a piston guide, a fastener holder, and a fastener aligner. The breech and trigger mechanism should be dismantled only by a qualified technician. This explosive actuated tool has a stop ring between the piston and the piston housing as a protective device. Protective devices may be of several types: rubber, soft metal, nylon, or a shear pin. Because of variations like these, operators should read the operator's manual of the specific tool they are using to become thoroughly familiar with its parts and its operation. Before firing an explosive actuated tool, a person must choose the proper fastener and the proper cartridge. Since there is a great variety of jobs for which an explosive actuated tool may be used, there are virtually hundreds of different fasteners available. These are some of them. But for a closer examination, ask your practical instructor or an explosive actuated tool representative to show you the complete range of fasteners that are available for each tool. The fastener must be the proper length, have the proper head design, and of course, it must be appropriate for the tool being used. There are also special purpose fasteners, including conduit clips, angle brackets, or eye pins. The operator should make sure that every fastener has a guide tip, guide washer, or some similar device. Choosing the correct fastener depends on both the material to be fastened and the kind of material to which it is being fastened. For instance, to fasten wooden plates to concrete, the pin will need a smooth shank with a fairly large head, or at least a washer under a smaller head. The length of the pin must be the thickness of the wood, plus 6 to 8 times the diameter of the shank, to ensure proper holding in the concrete. Another example, fastening 19mm plywood to 5mm steel. The fastener will need a threaded end so that the plywood can be removed and reinstalled. It will also need a knurled shank section to prevent it from turning as the nut is put on or taken off. The length of the threaded end is the thickness of the material to be fastened, plus enough length to accept a nut and perhaps a washer as well. The shank length will have to be long enough to ensure that the entire point is through the metal, while the taper below the threads is not touching the top of the metal. An alternative fastener to use for this job would have a shorter threaded section. Fasteners also have two categories: light duty and heavy duty. Light duty fasteners are used for general purpose applications, and heavy duty fasteners are used on jobs that require greater shear resistance, higher withdrawal resistance, and greater torque resistance. The light-duty fastener has a shank diameter of 4.83 millimeters or less, and the heavy-duty fastener has a shank diameter greater than 4.83 millimeters. There is a wide variety of cartridges available for low-velocity tools. Care must be taken to select the proper cartridge. Each manufacturer of a low-velocity tool has a specially designed cartridge for that tool. Low-velocity cartridges have two things in common. The cartridges are always crimped at the end, and the casing material is always brass. The crimped section of each individual cartridge is painted with an identifying color which indicates the power load strength of the cartridge. Cartridges are sold in containers, and these also distinguish the strength and the caliber of the particular cartridge. One means of identification is the color of the container, with the name of the color clearly printed on it. Another is a number which corresponds to the color. A third method employs a dial system, which shows where the number is in relation to the total range of the cartridge strengths. Low-velocity cartridge numbers range from 1 to 6, each number having a corresponding color. Cartridge load number 1, or gray, is the weakest. Each number is slightly more powerful than the preceding number, up to the strongest, number 6, or purple. Low-velocity tools have another, more powerful range of cartridges for heavy-duty tools. This range of cartridges has the same color and number system as light-duty cartridges, but there is one important difference. Heavy-duty cartridges are longer in length. Be sure you select the cartridge that meets your requirements. Before using an explosive actuated tool, an operator should dismantle and inspect the tool to ensure that it is in proper working order. Be sure the tool is not loaded by removing and inspecting the cartridge chamber. Next, retract the thumb latch and remove the barrel assembly. Remove the spring. Pull the piston from the barrel assembly and inspect. Remove the stop ring and stop ring holder from the piston and inspect for damage. With tools that have interchangeable pistons, the operator should check to see if the piston is the correct one for the fastener being used. This piston is not suitable for a threaded fastener and must be exchanged to suit the fastener selected. This is the correct piston for the fastener being used. When replacing the stop ring assembly, make sure the stop ring is facing the shoulder of the piston. And now, reassemble the barrel assembly. Place the barrel assembly back into the front unit. Turn it until the thumb latch clicks. Next, to ensure that all the parts are together properly, depress the tool and see that everything works smoothly. The tool will not fire unless it is fully depressed. This is a design feature that all explosive actuated tools must have. After you have selected the proper fastener for the job and the weakest cartridge for the tool you are using, after you have checked out the tool and put on the necessary safety equipment, you are ready to test fire the explosive actuated tool. Take the fastener you have selected and insert it head first into the muzzle of the tool until the tip is flush with the end of the barrel. Open the tool and into the cartridge chamber insert the lowest strength cartridge for that tool. With the barrel pointing down, make sure the cartridge is seated properly. Close the tool. Place the tool squarely on the material, depress, and fire. If the fastener does not penetrate as deep as required, you must run another test. Reload the tool with a new fastener. And the next strongest cartridge. Depress and fire. If this fastener still does not penetrate far enough, keep firing test shots, each time increasing the strength of the cartridge until the desired penetration is achieved. This is the desirable penetration for this type of fastener. Notice that the ballistic point is completely through the metal, and that the knurling of the fastener is entirely enclosed by the metal. The tapered portion of the fastener below the threads is not touching the metal. This pin is clearly underdriven. The cross-section shows that the ballistic point hasn't penetrated the metal completely, and the knurling is above the surface of the metal. In this example, the ballistic point has penetrated the metal. However, the knurling is barely in contact with the metal, and therefore the fastener is not at optimum efficiency. Here is an example of an overdriven fastener. Note that the knurling is through the metal. This reduces the torque resistance. Note that the tapered portion of the fastener is embedded in the metal. This seriously reduces the withdrawal strength. Ideal penetration is achieved when the ballistic point of a fastener is through the metal, when its knurling is completely enclosed by the metal, and its tapered portion is above the surface of the metal. When using explosive actuated tools, it is important to realize that there are specific standards that must be observed regarding the placement of fasteners. For example, this concrete slab, which is 88 millimeters thick, could take a light-duty fastener, but not a heavy-duty one. The standards for low-velocity tools are minimum concrete thickness for light-duty fasteners, 65 millimeters. For heavy-duty fasteners, 100 millimeters. Minimum edge distances for light-duty, 50 millimeters. For heavy-duty, 150 millimeters. The minimum distance between light-duty fasteners is 75 millimeters. For heavy-duty fasteners, 150 millimeters. For steel, minimum thickness for light-duty fasteners, 5 millimeters. For heavy-duty fasteners, 10 millimeters. The minimum edge distance in steel for both light and heavy-duty fasteners is 15 millimeters. The minimum distance between fasteners in steel for light and heavy-duty fasteners is 50 millimeters. The closest a fastener can be to a weld is 50 millimeters. And do not fasten within 50 millimeters of a pre-drilled hole. Occasionally, a tool will misfire. A misfire is what happens when a tool is loaded, depressed, the trigger is pulled, but there is no cartridge explosion. When this happens, an operator must wait 15 seconds before removing the tool from the work surface. This will ensure that the cartridge does not have a delayed explosion as the tool is opened. Then, the operator should open the tool away from himself and away from other people. A second attempt can be made with this same cartridge by replacing it so the firing pin will strike it in a new position. Depress and fire. A faulty cartridge should never be thrown away or left on the floor because it's possible that someone could be injured by it. The proper way to dispose of a cartridge is to drop it in a container of water, and it can be returned later to the supplier. Insert a new cartridge. Depress and fire. There are other reasons why a tool may not fire. It may be because the operator simply forgot to load a cartridge, or as serious as a broken firing pin. If this is the case, a field representative should be called. Sometimes, if the tool isn't held in a vertical position when loading it, this may happen. Reinsert the dislodged cartridge, making sure the tool is held in an upright position, and carefully close the tool. At the end of each day, or whenever the tool becomes slightly stiff or sluggish to use, it is necessary to clean it. You will need cleaning solution, an assortment of brushes for cleaning inside and outside the parts, and a supply of rags for wiping and drying the parts. Open the tool and remove the cartridge chamber. Depress the retaining catch and turn the retaining ring until the barrel assembly releases from the front assembly. Remove the compression spring and piston from the barrel assembly. And pull the stop ring and the stop ring holder from the piston. Release the stop ring from the holder. Now, turn the base plate 90 degrees and pull it out of the cylinder assembly. Remove the retaining ring. Apply the cleaning solution to the proper brush and clean the cartridge chamber, outside and inside. Cleaning will remove all carbon residue. A clean tool will operate more efficiently, thus resulting in better fastener penetration. When you finish cleaning the cartridge chamber, wipe it dry. An oily tool will get dirty faster than one that is clean and dry. Use the correct brushes and clean the following parts: the stop ring and stop ring holder, the piston, the cylinder, inside and outside. Clean the base plate, inside and outside. Clean the retaining ring and the compression spring. Clean the inside of the front assembly and the face of the breech assembly. Be sure to wipe all parts clean and dry. Then, reassemble the tool. Place the retaining ring over the cylinder, push the base plate into the cylinder, Place the stop ring into the stop ring holder and slip these parts over the piston. Remember that the stop ring is towards the shoulder of the piston. Place the piston into the cylinder assembly and place the compression spring over the piston and inside the cylinder. Slip this entire barrel assembly into the front housing and turn the retaining ring until the retaining catch snaps into place. Finally, place the cartridge chamber into the front assembly. Close the tool and check for ease of movement of all parts. The explosive actuated tool is ready for further safe use. The foregoing demonstrations use this tool because it is fairly typical of models used in the field. However, it is only one model. Explosive actuated tools do vary in design. You should always read the operator's manual before using a new or unfamiliar tool because it may differ considerably from the model used in this program. For example, this tool has a design feature which eliminates the necessity of manually inserting a cartridge each time it is to be fired. Its cartridges are held in a clip. The loading procedure is insert a fastener head first into the muzzle, then insert the clip into the pistol grip. When the clip is flush with the bottom of the grip, the first cartridge is in firing position. Depress and fire. To fire successive shots, reload with a new fastener, then cock the tool. This brings the second cartridge into position, ready to fire. This tool incorporates several interesting features. It has a unique loading procedure, has power adjustments, and uses clip-loaded cartridges. The fastener, instead of being placed head first into the barrel, is placed tip first into the cocking lever. Rotate the cocking lever 180 degrees and push the fastener into the barrel. This tool also uses cartridges that are held in a clip. When you're ready to fire, the clip is inserted into the bottom of the pistol grip. Another innovation of the tool is this dial system, which varies power supplied by any cartridge, and therefore the operator doesn't have to carry a complete range of cartridge strengths. It produces a highly accurate fastener penetration. The first test shots are fired with the pointer set at the number 1 position. Increased power for this same strength cartridge is obtained by turning this knurled wheel until the desired fastener penetration is attained. After inserting the fastener and setting the power selector, insert the cartridge, depress, and fire. This is an interesting model which employs an unusual cartridge clip. The clip is basically a hollow vinyl tube that slides onto a cartridge feed assembly. The clip is reloadable. With the barrel extended, insert the fastener, feed in a cartridge, depress, and fire. The low-velocity explosive actuated tool is a convenient and efficient tool, and every operator should learn to use and maintain it properly. In summary, remember your safety equipment. Use the proper fastener. Use the proper cartridge. Inspect the tool before using it. Remember to follow the placement standards. Learn the correct misfire procedures and the proper cleaning of the tool. By being careful, you will be safe.